we have seen that discrete time Fourier transform of xn is defined as summation of xn into e to the power minus j omega n, n going from minus infinity to plus infinity. We have seen that this is denoted by x e raised to j omega. This x of e to the power j omega is periodic. The only point is the time domain function xn is discrete and is also aperiodic. Minus infinity to plus infinity is aperiodic. This function can be represented in frequency domain by periodicity, periodic function of x e to the power j omega. Okay, so in the frequency domain it is periodic, in the time domain it is discrete. Have we seen a exact dual of this? Where did we see that? We have seen in the Fourier series case. What is Fourier series? Fourier series tells that any periodic function x of t can be written in the form of some Cn bar into e to the power minus j n plus j n omega 0 t, where n going from minus infinity to plus infinity. The two equations look alike. Do they look alike? The only point is the time domain is periodic, continuous and periodic. Cp stands for continuous and periodic, whereas Cn bar is discrete and aperiodic. It is discrete and aperiodic. Now this is exactly the dual of it, wherein we are writing x of e to the power j omega, which is a periodic function, continuous and periodic function, can be written as summation n going from minus infinity to plus infinity x of n into e to the power minus j omega n, where even if this is plus j, since this is going from minus to plus, it makes no difference. You understand? Here we wrote Cn bar is equal to 1 upon t integration xt into e to the power minus j n omega 0 t dt. What will it be here? How can you write applying this? How do you write xn here? This implies xn is equal to, tell me, 1 upon, what is the periodicity of x e to the power j omega? 2 pi, 1 upon 2 pi, integration, what is one period of x of e to the power j omega? Minus pi to plus pi, x of e to the power j omega into e to the power j omega n d omega. X of n is equal to 1 upon 2 pi x e to the power j omega e to the power j omega n d omega. Alright, the logic is same. Here this is called as dtft of x of n, written as Fourier transform of x of n. What is this? X of n is Fourier inverse of x e to the power j omega. Alright. So we have simply derived a simple relation between Fourier transform pair. Is that clear? So what we have seen just now is a proof for inverse Fourier transform. Alright? Okay. Before going to this, I had given you an exercise and some people asked me some problems. So let me complete that exercise here. How many of you want it to be completed here? The exercise was xn is given as 1 for 0 less than equal to n less than equal to 5 and is equal to 0 otherwise. Determine Fourier transform, discrete time Fourier transform of this. I hope everybody has obtained. The problem was only with reference to plotting the magnitude and phase function. The other function was no problem. That means evaluation of x e to the power j omega is no problem. What is it? It's e to the power minus j 5 by 2 omega into sine of 3 omega divided by sine of omega by 2. Up to this, there is no issue to anybody, any individual. The only point is to plot the magnitude and phase spectrum, all right, which I will complete now. Most of you, those who have sent me an email, has plotted sine 3 omega correctly and sine omega by 2 correctly, but they are not able to plot the sinc function, the ratio of 2. So I will do all the things here. Minus pi to plus pi, identify the regions. One more thing you must identify is, when will sine 3 omega be equal to 0? When 3 omega is equal to 0, plus minus pi, plus minus 2 pi and so on. So what is omega? Omega will be equal to 0, plus minus pi by 3, plus minus 2 pi by 3 and plus minus 3 pi by 3, which is pi. That is all. We are interested in minus pi to plus pi. So what are these regions now? We have to identify 3 parts here. So this is to be divided by 3. So pi by 3, 2 pi by 3 and this. So minus pi by 3, minus 2 pi by 3 and so on. Identify correspondingly for the phase spectrum as well. Now sine of 3 omega. So before going ahead, so these are the points at which it is 0. The magnitude function is 0 at these 3 points. When it is 0 means it is either going from positive to negative or negative to positive. Okay? Sine 3 omega will be positive here. I will write plus, minus here, plus here. Okay? Sine of 3 omega is minus here, plus here and minus here. This is the sign for sine of 3 omega. What is sine of omega by 2? Sine of omega by 2 is always positive on this side, negative on this side. I do not need to bother. When omega is greater than 0 and less than pi, sine of omega by 2 is positive and sine of omega by 2 is negative on this side. So overall, now this is sine of 3 omega by sine of omega by 2, sine of that. Sine of 3 omega by sine of omega by 2 has the sign plus here, minus here and plus here and plus here. Alright? Okay? Now you tell me what is the value at omega equal to 0. So sine of 3 omega by sine of omega by 2 is equal to sine of 3 omega by 3 omega multiplied by 3 omega by 2 multiplied by 2 divided by sine of omega by 2. So this, okay, this becomes 1, this becomes 1, so in all the value is 6. So this value is going to be 6 here somewhere, and then it alternates from positive to negative. So it has to be like this, a decaying sinusoid. This is the magnitude function. Alright, is that clear? It is going to be decaying. 6 is the largest value at omega equal to 0. You can verify that, you can find out the values at in between points as well, and you can identify the function. If the function is going to be like this. Okay? Now about the phase. Now what is the phase? Phase function phi of omega is minus 2.5 omega. So when omega is equal to minus pi, this becomes plus 2.5 pi. Is that right? So I will have to make pi, 2 pi, 3 pi here. So 0.25 pi will be here. This is what is 2.5 pi. Similarly on this side pi is here, 2 pi is here, and this is minus 2.5 pi. Ends. Maximum value of phase will be plus 2.5 pi on this side, minus 2.5 pi on this side, and it is a straight line joining 0 0. When omega equal to 0, phase is also 0. So it is the straight line. This is the phase value. But when now the magnitude function here is positive, so this remains, this will be the phase correspondingly. So also this is going to be the phase here as well as here. The only point is in between these two where the magnitude function is negative. What I have to do? I have to either plus pi, add, or subtract pi from it. Okay? Do whatever you want. Since it is already going above, what is the value here? This is 2.5 pi by 3. 2.5 is 5 by 2. So 5 by 6 pi. This value is 5 by 6 pi. How is that 5 by 6 pi? It is minus 2.5 times omega is pi by 3. 2.5 is written as 5 by 2. 5 by 2 into pi by 3 is 5 pi by 6. What is this value is going to be? Twice of this. That means this is 10 pi by 6. And 10 pi by 6 is above pi. So what I should do? I should subtract pi from this. So 10 pi by 6 minus pi is 4 pi by 6. So 4 pi by 6 is just below this, somewhere here. This is the point. And 5 pi by 6 minus pi will be minus pi by 6, so somewhere here. So it is the line joining these two. Same slope with a difference of pi. Alright. Similarly here it is going beyond minus pi. So what you should do? You should add plus pi. So add plus pi means what is this value going to be? This value is minus 5 by 6 pi. This value is minus 10 by 6 pi. This value is going to be minus 4 point this to this. Minus 2.5 pi plus pi will be this straight line, plus pi. Same slope but differing in y intercept. Y intercept is going to be pi for this straight line. Okay. Now this is all right. All up to this, it's between minus pi to plus pi. It is called as wrapped phase, or it is also called as, there is a term called principal value. Principal value of the phase, which is only in the range of minus pi to plus pi. Wrapped phase or principal value of the phase, that has to be in the range of minus pi to plus pi. So this is going to be plus 10 pi by 6. What is this going to be? This is 5 pi by 2. So I need to subtract now from this. This is going exceeding plus pi. So I must subtract 2 pi from it. This 2.5 pi minus 2 pi will be how much? 0.5 pi. 0.5 pi will be somewhere here. This value is going to be, before this, 10 pi by 6 minus 2 pi. Minus 2 pi by 6. Minus 2 pi by 6. 10 pi by 6 minus 2 pi. 10 pi by 6 minus 12 pi by 6. So it is minus 2 pi by 6. This is pi by 2. Here also it is going to be the same. So minus this will become plus pi by 2 or minus pi by 2, and this here. So it is the straight line like this. So your principal component of phase will be this. Did I make it clear? The phase value, how to plot the phase? Phase values are supposed to be only in the range of minus pi to plus pi. Whenever it exceeds, automatically, the first adjustment was due to magnitude negative. First step of adjustment was due to negative magnitude here. The second adjustment was due to the phase exceeding plus pi or minus pi. When it is exceeding plus pi or minus pi, you add or subtract 2 pi from it. And when it becomes negative, you add or subtract pi from it. Okay? Is it clear? Any question here? The other day we have also solved one more problem. Xn is equal to a to the power n u of n, and the Fourier transform of this was x of e to the power j omega is equal to 1 divided by 1 minus a e to the power minus j omega, provided mod a is less than 1. Can you plot this? So plot magnitude and phase of x e to the power j omega. So what is mod of x? 1 divided by square root of 1 minus a cos omega whole square plus a square sin square omega. This is mod x. This can be written as 1 divided by 1 minus a cos omega minus plus j times a times sin of omega. This is real part, this is imaginary part. So magnitude is square root of a square plus b square, a plus jb. And what is the phase? Argument of x e to the power j omega is, since this is in the denominator, it becomes minus tan inverse a times sin omega divided by 1 minus a times cos of omega. Okay? By varying the values of a and omega, you can plot it. Okay? You can take typical values and then plot. Which typical values? In the range of minus pi to plus pi, take any values. So magnitude will be minus pi plus pi. Usually we know the values of sine and cosine for pi by 6, pi by 4, pi by 3. Those are enough. So pi by 2, pi by 4, 3 pi by 4, then pi by 6, pi by 3, 2 pi by 3 and 5 pi by 6. These value if you find out on left hand side, this part will be exactly same as this part because it is magnitude function. For a, once again we will talk about that property little later. For a real value of xn, the magnitude response is an even function and phase is going to be an odd function, as we have checked in this case as well. See here, the given sequence was real, xn is equal to 1, so real sequence. For this, the magnitude function is an even function. Magnitude is an even function. Phase is an odd function, you see. Everywhere, whatever is this value, same is this value with negative sign. Alright, magnitude and phase, magnitude is an even function, phase is going to be an odd function for a real sequence. So, try to find out the value. Let us choose something like A is equal to 0.9. Unless you choose that, plotting will not be possible. A equal to 0.9 and then pi by 6, pi by 4, pi by 3. So, these are the values pi by 6, pi by 4, pi by 2. So, this is pi by 3. This is pi by 2. This is pi by 3. This is pi by 4. Pi by 6, pi by 4, pi by 3, pi by 2. This is going to be 3 pi by 4. This is 2 pi by 3. This is 5 pi by 6. So, at pi, what is the value? 1 divided by square root of 1 minus a cos omega square plus a square sin square omega. At omega equal to pi, sin omega is 0. At omega equal to 0, let us start with omega equal to 0. So, what is the value? It is 1 by 1 minus a e to the power minus j omega. 0 and pi values can be easily found out from this expression itself. What is the value of a? A is 0.9. What is omega? Omega is 0. So, this becomes 1. So, 1 by 1 minus 0.9, it becomes 0.1. What is it at pi? When this becomes pi, this becomes plus 1. Okay? So, it becomes 1 plus a. 1 plus a is 1.9. So, pi is 1.9. In between, it does not go to 0 any time. Is there a possibility for this to be equal to 0, mod of this to be equal to 0? Is there a possibility of cosine and sine? No possibility. So, it is going to be something like this. You can check. For example, in pi by 2, if you take in terms of pi by 2, this becomes 1 by 1 minus a e to the power minus j. Pi by 2 is what? Minus j. So, this becomes plus j times a. What is the magnitude? Square root of 1 plus a square. So, a square is 0.9. 1 by 1 plus a square. Did I make a mistake? Oh, it is not 1 by 1.9 is approximately 0.5. This is 1 by 1.9 and this is 1 by 0.1. I am sorry. Cross this. I will do it here. 0 and pi will find out. So, when omega equal to 0, this becomes 1 by 1 minus a. A is 0.9. 1 minus 0.9 is 0.1. 1 by 0.1 is 10. So, it is 10 here. At pi, it is 1 by 1 plus a. Plus a is 0.9, plus 0.9. 1 by 1 plus 0.9 is 1 by 1.9, approximately 1 by 2. Approximately 1 by 2 is 0.5. So, 0.5 is somewhere here. Alright. Now, pi by 2. At pi by 2, what is the value? Pi by 2, this becomes 1 minus a times e to the power minus j pi by 2. E to the power minus j pi by 2 is minus j. This becomes plus j. So, 1 by square root of 1 plus a square. A square is 0.81. 1 by 1.81. 1.81 square root. 1.4 has a 1.96 has a square root of 1.4. 1.69 is the square root of 1.69 is 1.3. So, it will be somewhere around 1.3 to 1.4. 1 by 1.4, how much? 0.7. So, it is growing. Let us take at pi by 6. What is that? What is the value of pi by 6? This becomes 1 divided by 1 minus a times cos of pi by 6 plus j times a times sin of pi by 6. Find out this. So, for this you need to substitute here omega is equal to pi by 6. Can you calculate the value and tell me? 1 minus a cos pi by 6 is how much? Root 3 by 2. Root 3 by 2 into 0.9. 1 minus root 3 by 2 into 0.9 whole square plus 0.9 square into sine square. Sine of omega is sine of pi by 6 1 by 2. This becomes 1 by 4. So a square by 4. Tell me that value, square root of that and 1 by square root. What is the value? Anybody? You are expected to find out 1 divided by square root of 1 minus 0.9 into square root 3 by 2 whole square plus 0.9 square divided by 4 square root. How much is it? 1.99. So approximately 2. So it's going to be something like this. That's the magnitude spectrum. All right. How do you plot this through a program? Simple for loop. For omega equal to minus pi colon 0.001 colon pi, k is equal to 1, capital X is equal to, capital X of k is equal to capital X of k plus xn times exponential of minus j star omega star k or n. There is a n loop here is also for n equal to 0 to say m or n whatever, and for this k is equal to k plus 1 and end for here. K equal to 1, I am not explaining x is equal to, write down whatever x is that. A to the power n un is 1, 0.9, 0.81 and so on. Or you write xn also can be written in the form of a loop. How do you generate xn? Xn can be generated like this: for n is equal to 0 to 100, n is equal to 0 colon 100 semicolon, and x is equal to 0.9 raised to n. This raised to n must be dot raised to n, so that it is pointwise raising. 0.9 raised to 0 is 1. This will generate, these two statements will generate the sequence as 1, 0.9, 0.81, 0.729 and so on. This is 0.9 cube, 0.9 to the power 4, 0.9 to the power 5, 0.9 to the power 6 and so on. Alright, these two statements, I rewrite those two statements here: n is equal to 0 colon 100 semicolon and x is equal to a raised to a dot raised to n. This dot raised to is a raised to 0, a raised to 1, a raised to 2, a raised to 100. Alright. This is not a to the power n un. What is a to the power n un? This 100 must be infinity. Infinity I cannot generate. So I am trying to approximate a to the power n un by 100 values. And you see 0.9 to the power 100, how much is it? 0.9 to the power 100. approximately 0.0000. So it's, so whatever are the values beyond 100, it's exactly same as 0.9 to the power of a to the power n into u of n. This is the sequence. After this, plotting the magnitude spectrum, Fourier transform and plotting the magnitude spectrum. Okay? Linearity property. What else? Shifting in time domain, shifting in frequency domain. These are the three properties we have seen. Sine, cos as well, modulation. Now let us see what is the Fourier transform of n multiplied by xn. Determine Fourier transform of n multiplied by xn. This is same as summation of n going from minus infinity to plus infinity n times xn into e to the power minus j omega n. Now looking to your background of a similar property that we have seen for a continuous Fourier transform, I want you to derive what is this. This is same as t into nt, t into ut or t into xt. What did we go? How did we go ahead? So we went ahead with x of e to the power j omega is equal to summation xn into e to the power minus j omega n. So take dx by d e to the power j omega. Take the derivative of both the sides with reference to e to the power j omega. So e to the power j omega as a function. So this becomes right hand side becomes xn is constant with reference to e to the power j omega. So it is x of n. The dd omega of this is e to the power minus j omega n and minus j times n. Minus minus jn. Minus jn is correct. Multiplied by minus j. What is derivative of this e to the power with reference to e to the power j omega? It's minus n. You are saying minus 1 here. What is that you are trying to say? E to the power j omega is derivative, no? Oh, this minus j will go. All these properties, proofs of each one of them we are not going to see because they are on the similar lines as that of CFT. We will see the convolution property in detail little later. At this moment, you please note down the property. Okay. We will also see some properties that we did not see at the time of continuous Fourier transform, but these properties also hold good for the continuous Fourier transform. We have seen in some form but let us write down these properties as well. I will explain these properties to you now. The first step explains, first sequence is xn. Xn could be real or complex. Xn could be real or complex. Xn could be a real sequence, Xn could be a complex sequence. For this Xn, the Fourier transform is x of e to the power j omega. X of e to the power j omega is going to be complex, which will have real part and an imaginary part, which is written in this form. Now x EVN denotes the even part of the sequence. So if the sequence is even, or I am sorry, the even part of this sequence xn will have Fourier transform that is real part of x e to the power j omega. Odd part of xn will have Fourier transform that is j times x imaginary part of e to the power j omega. Let me explain it to you, this particular property. Xn can be written as x even n plus x odd n. Any sequence can be written in the form of even and odd function. Every function will be written as the sum of an even function and an odd function. If xn has a Fourier transform x e to the power j omega, which is going to be complex, it is written as x real part of x e to the power j omega plus j times x imaginary part of e to the power j omega. Alright. So if this has this Fourier transform, this will have this will have this, that is all. How do you write x EVN? Suppose you want to write x even part of xn, you want to find out. How do you find it out? You write xn plus x of minus n divided by 2. Take the Fourier transform of both the sides. What is Fourier transform of xn? X e to the power j omega plus x of minus n, x star e to the power j omega divided by 2. What is the addition? What is the addition? X plus x star is twice real part. Twice real part means divided by 2 is real part of x. Real part of x e to the power j omega, which is written as x re e to the power j omega. That is the proof. Okay? Similarly, you can prove x odd n is equal to xn minus x of minus n divided by 2. This becomes imaginary part of x e to the power j omega, which is x im e to the power j omega. Okay. Now let us take symmetry properties. Now, the symmetry properties, note down the symmetry relations. X e to the power j omega is also equal to x star e to the power minus j omega. X real part of e to the power j omega is x real part of e to the power minus j omega. X imaginary part of e to the power j omega is minus x imaginary part of e to the power minus j omega. Mod of x e to the power j omega is also equal to mod of x e to the power minus j omega. This says that it is an even function. And the last property is argument of x e to the power j omega is minus argument of x e to the power minus j omega. This tells that the phase is an odd function. Okay. Do you want me to prove any one of these? Let us prove the first one, which is critical. The one that is critical is prove that x e to the power j omega is equal to x star e to the power minus j omega. Can you prove this? Take x e to the power j omega, which will be equal to summation of xn e to the power minus j omega n. Take x star e to the power j omega. What will this be? Summation of xn star. Star is e to the power j omega n, the complex conjugate, and replace omega by minus omega. This becomes x star e to the power minus j omega will be equal to summation xn e to the power minus j omega n, which is equal to x e to the power j omega. Okay. Let us take few more properties. Sequence is x of minus n. The Fourier transform is x of e to the power minus j omega. The sequence is x star of minus n. Third point, sequence is x star of minus n. The Fourier transform is capital X star e to the power j omega. The sequence is real part of xn. The Fourier transform is xcs, conjugate symmetric part of x e to the power j omega. Note down that xcs, cs is the subscript of capital X, cs stands for conjugate symmetric. x cs e to the power j omega, which is equal to half of x e to the power j omega plus x star e to the power minus j omega. Next sequence is j into imaginary part of xn, and the Fourier transform is xca. Ca stands for conjugate antisymmetric. xca e to the power j omega, which is equal to half x e to the power j omega minus x star e to the power minus j omega. Then it is the last 2 points are the duals of the earlier 2. The sequence is xcsn, conjugate symmetric part of xn. The Fourier transform is real x real e to the power j omega, and conjugate antisymmetric sequence n will have Fourier transform j times x imaginary e to the power j omega. This conjugate symmetric is equivalent to even in case of real functions. I repeat that part. Is that okay? Have you noted down that? Okay. X even function is x of n plus x of minus